Imagine a substance that rewrites the rules of physics, a form of gold so strange it challenges everything we know about matter, energy, and even the mind. This is monoatomic gold, a frontier where quantum science meets an ancient wisdom enigma. Often called white powder gold, or part of the mysterious orbitally rearranged monatomic elements, ORMUS. This material isn't the shiny metal you picture. It's a powder that gleams with glass-like clarity, its atoms isolated in a state that defies the metallic norm. First documented in the 1980s by Arizona farmer David Hudson, this white powder gold behaves unlike any element on Earth. Non-metallic, diamagnetic, and according to patents, it can levitate over magnets at room temperature, a telltale sign of potential superconductivity. In regular gold, atoms bond tightly in a lattice, giving it that familiar luster. But monoatomic gold, its atoms stand alone, their electrons rearranged into high-energy orbits. The result is a white powder that doesn't reflect light like metal, but scatters it like crystal, a clue to its bizarre properties. At the nanoscale, gold forms delicate nanowires, threads so stable they resist breaking under forces that would snap most materials. In 2023, Austrian physicists at TU Wien blasted gold nanoparticles with ion beams, sculpting wires 1 atom thick. These nanowires don't just bend, they self-heal, defying classical physics. Simulations reveal their electrons move in lockstep, enabling quantum tunneling, essentially teleporting through barriers like phantoms. Here's where it gets fascinating. Monoatomic gold might conduct electricity with zero resistance, even at room temperature. Researchers have observed it levitating over magnets, a phenomenon closely associated with superconductivity, where electrons pair up and glide without friction. This property could potentially unlock lossless energy systems or quantum sensors, revolutionizing how we harness power. In specialized laboratories, some researchers report that monoatomic gold particles sealed in glass vials mysteriously appear outside their containers. While mainstream researchers remain skeptical, quantum theorists propose an intriguing possibility: macroscopic coherence. Trillions of atoms acting as one giant quantum wave, similar to a Bose-Einstein condensate visible to the naked eye. The technological implications are staggering. Room temperature superconductors could dramatically reduce global energy waste. Quantum computers with gold atom circuits might process information at unprecedented speeds. Even more controversially, anecdotal reports suggest biological effects, claims that monoatomic gold repairs DNA and synchronizes brainwaves. The hypothesized mechanism involves quantum coherence resonating with microtubules in neurons, echoing Nobel laureate Roger Penrose's orchestrated objective reduction theory of consciousness. Despite the excitement, proceed with caution. Unregulated vendors sell monoatomic gold as a miracle supplement, despite having zero FDA approval. More concerning, its toxicity profile remains largely unknown. Some theorists even speculate, if this material truly interacts with fundamental forces, what are the implications? From ancient texts describing the Ark of the Covenant's manna to modern patents, monoatomic gold straddles the boundary between myth and scientific reality. The question isn't just, does it work, but should we manipulate quantum forces we don't fully understand? Or worse, could it be weaponized? From nanowires for futuristic circuits to potential superconductors, monoatomic gold could reshape technology. Imagine quantum computers wired with gold threads or power grids that never lose energy. Here's the reality. Much of this research exists at the intersection of established science and theoretical speculation. Yet the documented anomalies, levitation, quantum tunneling, coherence, demand serious scientific attention. Monoatomic gold sits at a fascinating crossroads, a material that's both scientifically documented and somewhat elusive, grounded in physics, yet reaching toward the unknown. It challenges us to ask big questions. What if quantum effects aren't confined to the subatomic? What if a single atom of gold could unlock secrets of energy, matter, and mind? As researchers dig deeper, This enigmatic substance might just light the way to a quantum future, or leave us marveling at a mystery we're not yet ready to solve.